Okay, I think recording started. We'll continue the session. Okay, so in the previous class, what are the things we have discussed are design of 4 to 2 line priority encoder. Okay, design of 4 to 2 line priority encoder. Okay, how it differs from conventional encoder? Can you people type it in the chat? Am I audible? Okay. How the priority encoder differs from the conventional encoder? Kindly you people type it in the chat. See, in the case of conventional encoder, at a time, any one of the input must be high. Okay. What about in the case of priority encoder? What about in the case of priority encoder? Kindly answer in chat, dear students. Okay, Jivita typed V equal to 1. Okay, so V equal to 1 means a valid combination of input. Okay, when we are giving the input, all the inputs are 0, 0, 0. Yes, Srihari, based on priority. That means more than one input can be high at a time, but at least one input must be high at a time. That is the condition for valid. Okay, so V is the bit we used for checking the validity of the data, whether the given input is valid or invalid. Okay, if we are giving a minimum logic 1 in any one of the input, that combination we term it as valid input. Fine. Whereas V equal to 0 means it is invalid combination. Fine. So what Srihari typed is correct. Based on priority, more than one input can be high at a time. Based on the priority, that particular input only encoded. Fine. Then we have discussed about 2 to 4 line decoder. Okay. Then we have discussed about 2 to 4 line decoder. Fine. Then we have discussed about the design of 3 to 8 line decoder. Can you people type it in the chat? If I am having 4 inputs to a decoder, what must be the number of output? If I am having 4 inputs to the line decoder, how many outputs must be there in the output? I am speaking about decoder, Srihari. If I am having 4 inputs to a decoder, how many outputs? Yes, Sabri Shetty, 2 to the power n. What I told n is equal to 4. So 16 outputs can be there. Fine. Then we have discussed how to use decoders as demultiplexer. What is the additional input we must be having in the decoder so that it can be used as demultiplexer? Can you people type it in the chat? Additionally, we must have one more input. Apart from the data, we have to provide one more input to the decoder. If a decoder, yes, enable, very good, Sabri Shetty, Jivita. If a decoder is provided with the enable input, okay, if E equal to 0 means the output is always 0, irrespective of the inputs. Fine. That means E must be made as 1, so that the decoder is enabled. So at the time it will work as a demultiplexer. This and all we have discussed in the previous session. Then finally we have discussed about Boolean function minimization using decoders. Okay, implementation of Boolean function using decoders. So using decoders, what about the outputs of decoder? Can you people type it in the chat? Decoder individual outputs ella edha represent pannumpa? What about the output of the decoders? Yes, very good, Jivita. Mintam, Srihari, Abhinaya, very good. Fine. That means to implement any Boolean function, you can just perform the OR operation of the given minterm. Fine. Now we will move to today's session. So in today's class, we are going to discuss about magnitude comparators. Okay. In today's class, we are going to discuss about magnitude comparators. Can you people type it in the chat? What about the purpose of this circuit? Any idea? Name itself indicate magnitude comparator. Comparator means what? What a comparator usually do? See, we are having the answer in the name itself. Yes, to compare, very good. Okay, magnitude comparator. What it differs? Magnitude comparators. So we are going to compare two numbers. Okay, what about magnitude comparator? We are going to just compare the magnitude of the given number. That means unsigned numbers can be compared with the help of this magnitude comparator. Fine. Okay, so we will go with the magnitude comparator. So magnitude comparator is a combinational logic circuit that compares two numbers. Only magnitude of unsigned numbers can be compared. Signed numbers நம்ம compare பண்ண முடியாது. Okay, whereas the magnitude of unsigned numbers can be compared. Okay, the other condition is each should be of same length. Each should be of same length. Say for example, if I am saying data A equal to n bit, what about the size of B? Can you people type it in the chat? If I am saying a data A of n bit data, what about the size of B must be? N bit only. Okay, so two n bit numbers we can able to compare. Fine. So we will see about the block diagram of a magnitude comparator, then we will go with the design. So A and B are the inputs, each are n bit unsigned numbers. You consider two numbers A and B. See, I am putting a wide arrow to indicate you are having multiple inputs. Say for example, A அப்படின்ற டேட்டால என்ன இருக்கலாம்? A0, A1, B, sorry, A2, A3 up to AN minus 1. Similarly, B0, B1, B2 up to Bn minus 1. That means A and B represent many bits. That means n bits. That's why I put the arrow wider way. Fine. Then it generates three 1-bit output. Okay, what are the outputs? G, E, L. G represent. Can you people type? What about the outcome of comparison of any two numbers? ரெண்டு நம்பர் நம்ம கம்பேர் பண்ணோம்னா அதோட அவுட்புட் என்னென்ன வரலாம்? Can you people type it in the chat? If I am comparing two numbers, what are the possible outcomes we can have? Kindly type it in the chat. Sabari Shetty, 1 or 0? I'm asking in general. I'm asking in general. Equal or not equal? Okay, equal is 1 point. Okay, what about not equal? Very good. Greater than, lesser than, equal. See, that's why that's the thing we have indicated here. Okay, G means A greater than B. With respect to A only we are speaking. A greater, A equal to B, A lesser, like that we can have. So these are the outputs of the magnitude comparator. See, simply to denote the meaning of the output variables, I have put a bracket and written the condition. A greater than B means this output G must be high. Okay, if A equal to B means E must be high. If A less than B means L must be high. Okay, is there any possibility to have all the more than one should be in the output? Is there any possibility? ரெண்டு நம்பர் கம்பேர் பண்ணா நமக்கு more than one possible outcome வரதுக்கு possibility இருக்கா? ஒன்னு greater இருக்க முடியும், இல்ல lesser இருக்க முடியும், or else it may be equal. Out of this three output, only one can be high at a time. Is it clear? Is it clear? Yes? Yes or no? Yes, okay. Now, so now we will design a 1-bit magnitude comparator. See, 1-bit magnitude comparator means A is going to have 1-bit data, B is going to have 1-bit data. So simply we are going to denote as AB. Fine? So 1-bit magnitude comparator. So the 1-bit inputs are AB simply. Here I have used a simple arrow. Okay, normal arrow that indicates each of 1 bit. What about the outputs here also? What about the outputs for this 1-bit magnitude comparator also? What are all the outputs must be there? Either it is n-bit data or 1-bit data, the outputs must be greater, equal, lesser. GEL, very good. Okay, GEL, very good. So this is the structure or block diagram of a 1-bit magnitude comparator. Now we are going to design it. Now we are going to design it. Okay, for designing any combinational circuit, what we have to do first? input variable assign பண்ணியாச்சு, output variable assign பண்ணியாச்சு, number of input variable, output variable naming பண்ணியாச்சு. Next step என்ன பண்ணணும்? What we have to do? Very good, Sabrisity, truth table. So now we are going to go with the truth table of 1-bit magnitude comparator. Fine. So A and B are two input. Is the arrow is visible? The arrow is visible. I'm pointing something in the screen. Is it visible? Yes. Okay. So A equal to 0, B equal to 0. What about the condition now? A-வும் B-யும் compare பண்ணா எனக்கு எந்த output வரும் நமக்கு? Both are 0, 0. What it mean? Equal. So அப்ப meaning என்ன? The output G is 0, L is 0. E மட்டும் என்ன பண்ணிருக்கோம்? 1. What about the next condition? A equal to 0, B equal to 1. A equal to 0, B equal to 1. Lesser. So அப்ப L க்கு நேரா என்ன பண்ணிருக்கோம்? We are marking 1. So the other combinations we marking it as 0. Okay. Now 1, 0. 1, 0 means what? A is greater than B. So G is equal to 1. What about for the last condition? Again it is 1, 1. So 1, 1 means what? Both are equal. So E must be 1. Okay. Now can you people type it in the chat? What about the output expression for G? Straight away you can write the expression. No need to go with K-map and all. 1 எங்க இருக்குன்னு பாருங்க. G ல where 1 is marked for the combination 1, 0. So what about the function? For greater, what about the expression? A, B bar. Very good. Super. Okay. So the output functions are A, B bar. What about for lesser? What about the function for L? L க்கு என்ன வரணும்ப்பா? Here it is 1. A bar B. Super. Very good. Fine. Is it clear? Now what about for equal? We are having two ones. So what about the function for equal? A bar B bar plus AB. Gayatri, kindly check it. It is A bar B bar plus AB. Sabrisity also correct. A bar B bar or AB. That means A bar B bar plus AB. We can write like this. What about the expression of the? What about the logic of this expression? A bar B bar plus AB. Which logic gate we can use? XNOR. Okay. So A XNOR B. How A XNOR B can be written as in terms of XOR? In terms of XOR la nam eppadi eludhalam? A XNOR of B in terms of XOR operation how I can write? XNOR XOR மாத்த சொல்றேன். அப்ப என்ன பண்ணிக்கணும் நம்ம? Whole bar. Very good. So A XOR B whole bar. How I can write A XOR B? How I can write A XOR B? A XOR B நான் எப்படி எழுதலாம்ப்பா? A bar B plus AB bar. Very good. Okay. So A B bar. Okay. A bar B. Whole bar. The whole bar அப்படியே இருக்குது. Now you tell me what is A B bar now? In our design, what is A B bar? Already we got the expression for an output. A B bar is nothing but G. Very good. Okay. A bar B is nothing but L. So I am replacing. So E of A comma B is equal to G plus L NOR operation. Clear? இன்னும் ரொம்ப சிம்பிளா சொல்லணும்னா ஒரு நம்பர் கிரேட்டரும் இல்ல லெஸ்ஸரும் இல்ல. கரெக்டா? அப்பனா மீனிங் என்ன? Greater or lesser complement. That is NOR operation. G NOR with L. Is it clear for all of you up to this? The expression புரிஞ்சுதா எல்லாருக்கும்? Kindly take a screenshot. I will move to next slide. Shall I proceed? Shall I proceed? Yes. Okay. So now we are going to draw the logic diagram. Okay. So the logic diagram is like this. See, A bar is available here, B is available here. So A bar B we are terming it as L. Okay. Similarly, B bar is there, A is here. So A B bar we are terming it as G. Fine. So here L is there, here G is there. NOR operation means simply what we can do. We can use NOR gate. Is the circuit diagram is clear for everyone? The circuit diagram எப்படி வரைஞ்சிருக்கும் புரிஞ்சுதா எல்லாருக்கும்? Yes. Okay. So that's all about the 1-bit magnitude comparator design. Okay. What about 2-bit? 2-bit அப்படின்னு சொன்னா என்ன பண்ணலாம்ப்பா? If I am saying 2-bit, what we can do? If I am saying 2-bit, what we can do? Two bit magnitude comparator அப்படின்னா ஏக்கு எத்தனை பிட் இருக்கணும், 2B க்கு எத்தனை பிட் இருக்கணும்? So totally how many inputs must be there? So totally how many inputs must be there? 3 or 4? Kindly check it, Sabri. I am saying 2-bit magnitude comparator. So here 1 bit means AB simply. If I am saying 2 bit means A1 A0, B1 B0. Yes, very good, Sabri. 4. Okay. Very good, Srihari, Jeevita, Jayavardhani. Okay. So in that case also you can go with K-map table. Correct? So adukku neenga K-map போட்டு போயிடலாம். Fine. So what we are going to discuss next is 4-bit magnitude comparator. Can you people type it in the chat? So what about the number of inputs now? What about the number of inputs now? 8 is the correct answer, Sabarish. 8 is the correct. That what you have typed is correct. Okay. For A, data A, you must be having 4 bits. For data B, you must be having another 4 bits. Okay. So it will be like this. So 4-bit magnitude comparator, it is going to compare two 4-bit signed numbers A and B as input. Okay. So the number A is represented as A3, A2, A1, A0. B is represented as B3, B2, B1, B0. So it looks like this. So what about the output? Number of outputs? What about the number of outputs? After comparing these two numbers, what about the outputs? 4 output. Srihari, kindly check your answer. Whatever the number of bits I am comparing, the outcomes are greater, lesser, equal only. So how many output must be there? 3 only. Is it clear for all of you? See, நான் எத்தனை பிட் இன்புட் வேணாலும் கம்பேர் பண்ணலாம்ப்பா. ஆனா என்னோட அவுட்கம் என்னது? Whether both the numbers are equal, okay, or lesser or greater. Clear? So here also you are going to have only 3 outputs. Okay. GEL. Is it clear for all of you up to this? Is it clear for all of you up to this? Yes. Okay. Now I am having a question. Can we go with truth table and K-map for this approach? We already designed 1-bit magnitude comparator. Okay. Now I am asked to design a 4-bit magnitude comparator. What we can do now? So 8 inputs அப்படின்னா 2 to the power 8, 256 input combinations வரும். ஸோ அதுக்கு நம்ம அவுட்புட் எழுதணும். ஸோ அதுக்கு K-map நம்ம போக முடியாது. How we can do? We have told one approach. If I am having a single block, using that you can build multiple blocks of n size. Okay, what is that approach? A design approach we are going to use now is modular design. Very good, Jeevita. Very good. So we are going to use modular design approach. When we have to go with modular design approach? When the number of input variable is greater than 6. Up to 6 variable you can go for K-map. ஆனா நம்ம கிளாஸ்ல டீச் பண்ணதும் 5 வேரியபிள் வரைக்கும் தான் கிளாஸ்ல டீச் பண்ணியிருக்கோம். கரெக்டா? ஸோ 6 வேரியபிள் போனா இன்னும் கஷ்டம் தான். பட் 7, 8லாம் போறப்ப it will be very very difficult. So up to 6 variable you can go with K-map. Fine. So modular design approach. Now you people tell me how many 1-bit magnitude comparator I need to build a 4-bit magnitude comparator. எத்தனை 1-bit magnitude comparator எனக்கு வேணும் to design a 4-bit magnitude comparator? Any idea? Each 1-bit magnitude comparator, okay, can be used to compare only 1 bits. That means 2 1 bits. Fine. So now the question is, how many number of 1-bit magnitude comparator I have to use to build a 4-bit magnitude comparator? Any idea? Yes, very good, Sabri Shetty. 4. Yes, very good. Okay. So to build a 4-bit magnitude comparator, 4 1-bit magnitude comparators are needed. Fine. So next, So each 1-bit magnitude comparator, what about the outputs? For each 1-bit magnitude comparator, how many outputs will be there? 3 outputs. Okay, what are the 3 outputs? We can see. So the output of each comparator are denoted as follow. Okay, in general, I am representing with I. I indicates what? The bit position. Okay, if I am saying I equal to 0 means A0 greater than B0. So for G0. So what about the outputs for greater from each magnitude comparator, 1-bit magnitude comparator? G3, G2, G1, G0. Instead of G, I am notating with a number. Is it clear? What about for equal? What about for equal outputs? What about for equal output? E3, E2, E1, E0. Very good. Okay, what about for lesser? Yes, L3, L2, L1, L0. Okay, so totally we will be having 12 outputs. Okay, from 4 1-bit magnitude comparator. Okay, using this 12 output, I am going to generate the function GEL. Okay, where GEL are the final compared value of the two numbers, 4-bit numbers. Shall we proceed? Shall we proceed? Shall we proceed? Yes, okay. Now, condition for a 4-bit number A greater than B. A greater than B இருக்குன்னா conditions என்னன்னு பார்க்கலாமா? First thing, condition 1. Okay, we are having this combination A equal to 1, B equal to 0. The MSB. See, when you are comparing two numbers, from which side you will look for the numbers? Say for example, I am typing in the chat 98, okay, compare with, okay, 98 வேணாம், ஒரு பெரிய நம்பர் எடுத்துக்கலாம், 98025. Okay, it has to be compared with 78923. How will you compare? If I am asking you to compare like these two numbers, how will you compare? Whether you compare from the LSB or MSB, very good. First number means MSB, Sabarish. Okay, Srihari typed MSB. Okay, so the most significant digit. If the first digit itself greater, A la greater or B oda, correct? So whether we need to compare the remaining digits, remaining bits compare பண்ணனும் அவசியம் இருக்கா? Yes or no? No. Fine. So இப்போ condition 1 என்ன சொல்றோம் அப்படின்னு பாத்தீங்கன்னா, to which bit it correspond to? எந்த பிட் இப்ப நம்ம கம்பேர் பண்ணியிருக்கோம்? தேர்ட் பிட். கரெக்டா? சோ இப்போ இதோட அவுட்கம் என்ன சொல்லலாம்? A3 greater than B3. கரெக்டா? Is it clear? இதை நான் எப்படி சொல்லலாம்? A3 greater than B3. கரெக்டா? A3 greater than B3. So that output 1 becomes G3. So G3 மட்டும்தான் 1 இருக்கணும். Is it clear now? Is it clear now? நான் சொல்ற கண்டிஷன் புரிஞ்சுதுங்களா? MSB பிட்டை கம்பேர் பண்றோம். MSB பிட் A greater than B இருந்தாலே நம்ம என்ன பண்ணிடலாம்? Simply we can write A greater than B. Is it clear now? See, ஏதாவது டவுட் இருந்துச்சுன்னா you kindly type it in the chat. Okay, G3 how? A3 greater than B3 அப்படின்னு சொன்னோம்னா மீனிங் என்ன? Which one of the output will be high? See, இந்த I mean A3யும் B3யும் கம்பேர் பண்ணா எந்த அவுட்புட் எனக்கு ஹையா இருக்கும்? See, we are having 4 magnitude comparator, 1-bit magnitude comparator. In that we are considering only the MSB now. If A3 greater than B3, which one of the output of the 1-bit magnitude comparator must be high? So 4 magnitude comparatorல, okay, magnitude comparator 4. Say for example LSB 1 ன்னு வச்சுக்கலாம், 1 2 3 4. So 4th comparatorோட output G3 மட்டும்தான் high இருக்க முடியும். Is it clear now, Sabri Shetty? I will have one more table later. Okay, fine. Now next condition என்ன சொல்றோம் அப்படின்னு பாத்தீங்கன்னா, if The MSB bits are same. Either it may be 0 0 or 1 1. எது வேணா இருக்கலாம். சரிங்களா? நான் இங்க 0 தான் எக்ஸாம்பிளுக்கு போட்டிருக்கேன்ப்பா. You may also have 1 1 also. For comparison purpose, I am using a sample example. சொல்றது புரியுதுங்களா? If A3 equal to B3. So அப்ப நான் என்ன பண்ணணும்? Which bit I have to compare next? If A3, B3 are equal, next which two bits I have to compare? Next எந்த பிட்டை கம்பேர் பண்ணும்பா? A2, B2. Very good. Now A2 1, B2 0. What it mean? Now also A is greater than B. Correct? Now also A is greater than B. See, for example, here I marked as 0 0. It can be 1 1 also. இங்க நமக்கு 1 1 இருந்தாலும் meaning என்ன? You can also have 1 1 here. What the thing we came to say here is, if MSB bits are same, we have to compare the next bit. So what about the conditions for this? The condition எப்படி எழுதலாம்? How we can write the condition? If A3 and B3 are equal and A2 greater than B2, correct? A3 B3 equal, okay, and means what? Both condition must be satisfied. A3 B3 equal இருந்து A2 B2, A2 greater than B2 இருந்துச்சுன்னா, that time also A greater than B. Is it clear for all of you? Is it clear for all of you? Yes or no? Now the third bits are same. Yes, so we can write it as E3 dot G2. A3 யும் B3 equal இருந்தா எந்த output 1 வரும்? E3. A2 greater than B2 means what? G2. Correct? Okay, now third condition. If the first two bits MSB and the next bit both are same, I have to compare the next bit. Okay, in that case, can you write the function for this? I will tell the condition A3 equal to B3 and A2 equal to B2 and A1 greater than B1. What about the function for this condition? What about the function for this condition? Can you people type? Yes, E3, E2, G1. Very good, super. E3, E2, G1. Okay, the last condition. If all bits are same except the LSB. Okay, so the condition is like this. Can you people type it in the chat? What about for the function for condition 4? Yes, E3, E2, E1, G0. All these things are in AND operation. Fine. Now you tell me how I can write the function G now. ரெண்டு நம்பர் கம்பேர் பண்ணி எனக்கு A தான் கிரேட்டர்னா இதான் பாசிபிள் காம்பினேஷன்ஸ். கரெக்டா? These are the possible combination. See here na 0 அப்படின்னு போட்டிருக்குது for your understanding. Here it can also be 1 1 1 1 இருக்கலாம் எல்லாமே. The ultimate aim is both bits are same இருந்துச்சுன்னா next bits we have to compare. Fine. Now you people tell me what about the final expression for G? Condition 1 or condition 2 or condition 3 or condition 4. If any one of the condition is true, then A greater than B. Can we say like that? Can we say like that? Yes or no? Yes. So what about the expression for capital G? Can you people type it in the chat? அப்ப Gன்றதை நான் சிம்பிளி எப்படி எழுதிட்டு போயிடலாம்? Or operation of all the conditions. Yes, sum. Okay. So it must be like this. Is this clear for all of you? Is this clear for everyone? Yes or no? Yes. Okay, fine. Okay, now I will move to next slide. If you want, you can take a screenshot of this. See, for your understanding only, I have taken this condition and I have explained the things. Okay, fine. Take a screenshot of this also. I will move to next slide. So next what we are going to do? Equal. Okay, we are going to find the function for E. So the condition for the 4-bit number A equal to B என்ன இருக்க முடியும்? Condition 1 எல்லாமே 0. A all bits are 0, B all bits are 0. What it mean? A3 equal to B3, A2 equal to B2, A1 equal to B1, A0 equal to B1. So E3, E2, E1, E0. Correct? All the condition must be satisfied. Fine. Second condition, it can be like this: 0, 0, 0, 1, 0, 0, 0, 1. Fine. That time also we have same condition. What about condition 3? Up to 16 numbers we can have like this. Is it clear for all of you? Condition 1 இருக்கட்டும், condition 2 இருக்கட்டும், condition 16 இருக்கட்டும். In between we are having many other combination. So அதை நான் இங்கே காமிக்கல. The ultimate aim is all the bits of A is equal to all the bits of B. இருந்தா மட்டும்தான் என்னது equal அப்படின்னு சொல்றோம். Clear? So what about the function? The condition எல்லாமே R பண்ணீங்கன்னா என்ன கிடைக்கும்? எல்லாமே E3, E2, E1, E0. So what about the final expression for E? Can you people type it in the chat? E3, E2, E1, E0 or with E3, E2, E1, E0 or with E3, E2, E1, E0. How many times I can do? What about the final expression? Kindly type it in the chat. Final expression for E. Expression என்ன வரும்பா? If you perform R operation of all the condition also, see 16 times நமக்கு வரும். ஓகேவா? அப்ப நான் என்ன கேக்குறேன்னா, yes, very good Sabrishati. 16 times அப்படின்னு சொல்றதுக்கு பதிலா சௌமியா ரவி டைப் பண்ணிருக்காங்க, ஸ்ரீஹரி டைப் பண்ணிருக்காங்க. That is the correct one. Okay. See, E3, E2, E1, E0, how many times you can perform R with the same thing, you will be get the same output. So the final expression is E3, E2, E1, E0 alone. Fine? Okay, now for lesser condition, A less than B condition, MSB we are checking. Okay, now in this case, A is lesser than B. Okay, MSB compare பண்றோம். So அப்ப என்ன expression எழுதலாம் இங்க? Condition 1 க்கு என்ன expression வரும்? Can you people type it in the chat? A3 less than B3 அப்படின்னா எந்த அவுட்புட் எனக்கு ஹையா இருக்கும்? L3, very good, super. Okay, next condition 2. MSB bit same இருக்குன்னு வச்சுக்கலாம். Next bit compare பண்றப்ப again A2 less than B2. What about the expression here? Kindly type it in the chat. Yes, E3 dot L2. Very good. E3 dot L2. What about for condition 3? E3, E2, E1. Sorry, E3, E2, L1. That is the correct answer. So for last condition, we'll be having E3, E2, E1, L0. What about the expression for L now? What about the expression for L now? R operation. Very good. So this is the thing. So L3 plus E3, L2 plus E3, E2, L1, E3, E2, E1, L0. Fine. So the final circuit we will discuss. So இப்போ நம்ம 3 ஃபங்க்ஷன் இருக்கா, G, E, L. All are derived from the outputs of 1-bit magnitude comparator. நல்லா கவனிச்சீங்கன்னா தெரியும், இந்த ஃபங்க்ஷன்ல வந்திருக்க எல்லா வேரியபிளும் என்னது? அவுட்புட் ஆஃப் த ஃபர்ஸ்ட் ஸ்டேஜ். ஸோ 1-bit magnitude கம்பேர் பண்ணதோட அவுட்புட் தான் இங்கே எனக்கு எல்லா ஸ்டேஜ்லையும் இருக்கும். ஐ மீன் ஃபார் ஆல் த 4 bits கம்பேர் பண்ணோம்னா நமக்கு வரக்கூடிய அவுட்புட்ஸ் தான் இங்கே ஃபங்க்ஷன்ஸ்ல இருக்குது. In terms of the output of 1-bit magnitude comparator only, the output function L is there. Okay, similarly G, E and all. Fine. Now, this you can draw in your exam. இந்த டேபிள் நீங்க எக்ஸாம்ல வரைஞ்சா போதும். இங்க நான் என்ன பண்ணிருக்கேன் அப்படின்னா C3, C2, C1, C0 கம்பேரட்டரோட அவுட்புட் அப்படின்னு ஜெனரலா எடுத்துக்கலாம். ஓகே, C0 represent okay LSB, the least significant bit. A3 sorry A0, B0 கம்பேர் பண்ணி கிடைக்கக்கூடிய ரிசல்ட் என்னென்ன இருக்கலாம்ன்றது தான் இங்க காம்பினேஷன் சொல்லியிருக்கோம். நல்லா கவனிங்க. G3 அப்படின்னு அவுட்புட் வந்துருச்சுன்னா கம்பேரட்டர் 3, மேக்னிடியூட் கம்பேரட்டர் 3, 1-bit மேக்னிடியூட் கம்பேரட்டர்ல 3. ஓகே, த தேர்ட் கம்பேரட்டர் அதுல எனக்கு கிரேட்டர் அப்படின்னு வந்துருச்சுன்னா ரிமைனிங் ஆர் டோன்ட் கேர். ஃபைன். அடுத்த கண்டிஷன் என்ன சொன்னோம்? MSB magnitude comparatorல வந்து output வந்து எனக்கு E3 னு வந்துருச்சுனா next bit we have to check. அது G2 னு வந்துச்சுனா next we can neglect it. So like that I have written. Is this table is clear for everyone? See, why I have marked a different color is for your better understanding. Okay, so first 4 row எதுக்கு A greater than B மட்டும்தான் 1 இருக்கு. Okay, then இந்த row பாத்தீங்கன்னா A equal to B. The remaining 4 rows, okay, A less than B. Is it clear for all of you? Yes. See, நம்ம அங்க ஒவ்வொரு காம்பினேஷனா எழுதி காமிச்சதை a combined table நம்ம ரெப்ரசன்ட் பண்ணியிருக்கோம். Okay, fine. So this you have to draw during your examination. இந்த இதெல்லாம் நீங்க எழுத வேண்டாம், இதெல்லாம் போட வேண்டாம், நிறைய டைம் எடுக்கும். No need to do like this. Straight away you can have this table. Okay, fine. So this is the circuit diagram of the 4-bit magnitude comparator. So we are having, I will mark a box so that you can understand. So this one, okay, this one, it is magnitude comparator C3 னு சொன்னோம், comparator 3, correct? Fine. This one is comparator 2. Okay, so this one is comparator 1. This one is comparator 0. So 4 1-bit magnitude comparator we are having. Each magnitude comparator we are having the output as we named. As it is A3 B3, here L3 E3 G3, L2 E2 G2, L1 E1 G1, L0 E0 G0. Okay. For example, if we are considering A equal to B, என்னென்ன terms வருது பாருங்க. E3, that is one input for this AND gate. The next input is E2, then E1 E0. All the 4 terms E3 E2 E1 E0 and பண்ணோம்னா A equal to B. Clear? Next L3 க்கு நம்ம என்ன பண்ணிருக்கோம் பாருங்க. L3 R with E3 L2. நல்லா கவனிச்சீங்கன்னா தெரியும், E3 யும் இங்க என்ன வருது அவுட்புட்ல, we are having E3 L2. So next function எடுத்துக்கிட்டீங்கன்னா எனக்கு என்ன வரணும், E3, okay, E3 L1. clear? E3 E2 L1 நல்லா கவனிச்சீங்கன்னா தெரியும். இந்த டாட் எங்க இருந்து வருது பாருங்க, from E3, this one from E2 and the third input from L1. okay, so similarly you have to draw. See, உங்களுக்கு எக்ஸாம் பொறுத்த வரைக்கும் 4-bit magnitude comparator கேட்க மாட்டோம். The reason is the circuit is somehow complex. Fine. So you peoples can be asked any size, okay, so that you can answer for your exams. எக்ஸாம்ல நமக்கு 1 bit தான் கேட்கணும், 4 bit தான் கேட்கணும்னு எதிர்பார்த்துட்டு உட்கார்ந்திருக்காங்க. சரியா? சோ எத்தனை பிட் கொடுத்தாலும் இந்த ப்ரொசீஜரை அப்ளை பண்ணிக்கணும். That's it. Okay, is it clear for all of you? Is it clear for all of you? Can you see it now? Srihari, can you see it now? Yes, okay. Kindly take a screenshot of this diagram. Okay, so now I will move with the next topic. So today we have discussed so far 1-bit magnitude comparator and 4-bit magnitude comparator. So underline the word magnitude comparator. Okay, see, normally ரெண்டு நம்பர் கம்பேர் பண்றப்ப பாசிட்டிவ் அண்ட் நெகட்டிவ் ஆன் கம்பேர் பண்ண முடியும் with respect to sign. So MSB வந்து நம்ம செக் பண்ணிட்டு அதுக்கப்புறம் நம்ம என்ன பண்ணலாம், we can compare. But this comparator we call it as magnitude comparator. Slide number 14 12 வேணுமா? Okay, so slide number 14 note பண்ணிக்கோங்க. Sabri Shetty, kindly take a screenshot. Yes, Srihari, we can have 2-bit and 3-bit magnitude comparator. N bit we can go, 8-bit போலாம். If I am saying 8-bit magnitude comparator, what you can do? You can use 2 4-bit magnitude comparator. Clear? See, if I ask you to design 8-bit, you should not go with this approach. 1 bit 8 வச்சு பண்ணோம்னா complex ஆயிடும். Correct? At the time, what you have to do? You have to use 2 4-bit magnitude comparator. Is it clear, Srihari? Yes. Okay. Slide number 12. Okay, slide number 12. Note பண்ணிக்கோங்கப்பா. Have you note down, Sabri Shetty? Shall I proceed? Yes. Okay. So now we are going to discuss about parity generator and parity checker. Okay. In your module 1, we have teach parity code. அப்படின்னு சொல்லி ஒரு டாபிக் டீச் பண்ணியிருப்போம். Few of you people told we cannot able to understand it, sir. எங்களுக்கு திரும்ப சொல்லி தர முடியுமான்னு கேட்டிருந்தீங்க. Fine. It's the time to discuss it here. Okay. Parity generator and parity checker. Okay. First of all, we have to know what do you mean by parity bit. Parity bit na enna? If I am having a message, okay, if I am having a message, along with it, I am going to add one more bit called parity bit, such that it should form either odd parity always or even parity always. Okay, fine. So the parity bit is an additional bit added along with the binary message to generate or check. Nalla gavaninga, underline this word, generate or check. Generate or check. That means you can generate this bit or you can check this bit. Fine. Generate பண்றோம் அப்படின்னா transmitter side we will generate, in the receiver side we will check. So parity generator எங்க யூஸ் பண்ணணும்? Transmitting sideல. Okay, receiving sideல parity checker circuit we have to use. We are having two circuit. One is parity generator, the other one is parity checker. Fine. So now we will move to next point. While receiving the binary information, this bit is used for error detection. So parity bit நம்ம எதுக்காக யூஸ் பண்றோம்? மெசேஜ் மட்டும் இருந்தா போதாது. This parity bit must also be there along with your message so that we can detect the error. Okay. So the main purpose of parity bit is to detect the error. If there is an error in the message, the receiver requests the transmitter to retransmit the information last sent. Okay. If there is an error, எனக்கு parity error இருந்துச்சு அப்படின்னா என்ன பண்ணணும்? Receiver has to request the transmitter to send the data again. Fine. Now, parity generator. We will go with parity generator. So parity generator is a combinational circuit that generates the parity bit in the transmitter side. That is called parity generator. Okay. That is called a parity generator. So parity generator is a combinational circuit that generates the parity bit either odd or even. That you have to decide. The user has to decide. Parity generator na adula rendu type irukku. Enna irukku? Odd parity generator, even parity generator nu rendu type irukku. Fine. So a parity generator is used to generate either odd parity or even parity, so that your entire information, it is going to be odd parity or even parity. Okay. Fine. The parity bit is sent along with the message. So already nama solliyachi. So types of parity generator. Even parity generated we are having. In that case, the generated parity bit along with your message, okay, must have even number of ones. Parity bitum enoda message bitsum combined ah எனக்கு எப்படி இருக்கணும்? Even number of ones இருக்கணும். இருந்துச்சுன்னா அது என்ன சொல்லணும்? Even parity generator. Fine. Odd parity generator means what? Parity bit along with your message always produce odd parity. That means odd number of ones. Okay. Fine. So now we are going to design a 3-bit even parity generator. So 3-bit means what are the, how many possible combination of inputs? So we are going to straight away go with the truth table. So we consider A, B, C are the 3 inputs. A, B, C are the 3 inputs. If I am saying 3 inputs, how many possible input combination I can have? Truth table எத்தனை combination வரும்பா? If I'm saying 3 inputs, how many combination of inputs I can have? Kindly type it in the chat. No answers. See, 3 input இருந்தா input combination எத்தனை combination வரும்னு கேக்குறேன். எத்தனை min term இருக்கும்? This one kindly check whether it is 9. 8 is the correct answer. Very good. Okay, I appreciate your response for trying the best. Fine. So here we said 3-bit message A, B, C, and we are having the parity bit named as P. So the input 3-bit message அப்படின்னு சொன்னோம்னா meaning என்ன? We should have 3 bit that are represented as A, B, C. You can also use the notation A2, A1, A0. That's your choice. சொல்றது புரியுதுங்களா? எனக்கு இப்படிதான் நேமிங் பண்ணணும்னு கிடையாது, பட் the naming must give some meaning. புரியுற மாதிரி இருக்கணும். Clear? So 0, 0, 0. What must be I add as a parity bit to get even parity? Is the slide is visible? Is the slide is visible for all of you? Yes? Yes. Okay. So what my question is, my message, it is going to have 0, 0, 0. All the bits are 0. Okay, now it is even parity. What parity bit I must be add so that the entire thing, இதெல்லாம் சேர்த்து எனக்கு even parity வரணும்னா என்ன bit நான் இங்க போடணும்னு பாருங்க. Already it is even parity. If I am adding 0 as the parity bit, the message remains even. Is it clear? Is it clear? What about for this combination? Sorry. What about for this combination? We are having only one ones in the message. So message எனக்கு எப்படி இருக்கு? Odd parity இருக்குது. To make it as even parity, so parity bit நான் என்னன்னு மார்க் பண்ணியிருக்கிறேன்? I marked it as 1. So message plus your parity bit always have even number of ones. You can check it. எல்லா ஆப்ஷன்ஸும் செக் பண்ணி பாருங்க. All the 8 combination input along with parity bit எப்படி இருக்கு பாருங்க. Number of ones must be even. Is it clear for all of you? Is it clear for all of you? Yes? Half screen தான் விசிபிளா இருந்துச்சா? சாரி. சரி, நம்ம என்ன சொல்ல வரோம் அப்படின்னு பாத்தீங்கன்னா, parity bit along with message எப்பவுமே எனக்கு என்ன இருக்கு பாருங்க. say for example last combination எடுத்துக்கோங்க, 1 1 1 1, 4 ones are there along with parity bit, messageம் சேர்த்து எனக்கு எத்தனை ones இருக்கு? 4 ones. Okay, if I am taking the fourth combination 0 1 1, okay, so already it is even parity, so parity bit 0 போட்டா it remains even parity. Is it clear? Is the slide is visible now? Full slide visible இருக்கப்பா? Yes. புரிஞ்சுதா இது? Have you people understand this truth table? Yes. Okay. Now, what are the minterms we are having in the function? P is the output function. What are all the minterms we are having? Minterm 1, 2, 4 and 7. Correct? Yes, minterm 1, 2, 4, 7. M must be small letter. Okay. So we will go with the K map. So K map போடணும்னா எத்தனை செல் போடணும்ப்பா இங்க? How many cells must be there in the K map? We are having 3 inputs. Okay. So how many cells must be there in the K map? 8 cell. So 1, 2, 4, 7 mark பண்ணிருக்கு. Fine. There is no possibility of grouping more than one ones. Fine. So we are doing single grouping. All the ones are grouped single. So the expressions are, what are the expression we can get? Kindly type it in the chat. So first single group, அதுக்கு என்ன expression வரும்? A bar, B bar, C. Correct? Okay. Similarly for next, For the next one, A bar, B, C bar. Very good. What about for the next one? What about for the next one? A, B bar, C bar. What about for the last one? Okay, so இப்போ K-map எல்லாருக்குமே நல்லா புரிஞ்சிருச்சு. Fine. So the expression is like this. A bar, B bar, C, A bar, B, C bar, A, B bar, C bar, ABC. Fine. இதில் நம்ம என்ன பண்றோம் அப்படின்னு பார்த்தீங்கன்னா A bar காமனா எடுக்கிறோம் ஃபர்ஸ்ட் அண்ட் செகண்ட் டேர்ம்ல. அப்போ B bar, C bar plus B, C bar. Similarly, second, third and fourth ல A காமனா எடுத்தோம்னா B bar, C bar plus BC. Fine. So this can be written as B XOR C. This can be written as B XOR C. Fine. It can be also represented in terms of XOR like this. B XOR C whole complement. Now it looks like A bar B plus A B bar. So finally A XOR B XOR C. That is the final thing. So what about the output function P? A XOR B XOR C. XOR of all the bits. That is going to generate the parity bit. Is it clear for all of you? Yes or no? Yes. So the circuit looks like this. A XOR B XOR with C. So this is the circuit for even parity generator. Even parity generator. Can you people type it in the chat? What about for odd parity generator? Yes, very good. All the things must be yes, like that also we can do Srihari. கடைசியா நம்ம கிடைக்கிற அவுட்புட்டை காம்ப்ளிமெண்ட் பண்ணிட்டோம்னா மீனிங் என்ன? டெஃபினெட்லி இட் இஸ் கோயிங் டு பி ஆட் பேரிட்டி. பட் டிசைன் பண்ணீங்க அப்படின்னா மீனிங் என்ன கிடைக்கும் அப்படின்னு பார்த்தீங்கன்னா A XNOR B XNOR Cன்னு கிடைச்சிருக்கும். ஓகே, யூ பீப்புள் ட்ரை ஆன் யுவர் ஓன். 3-bit ஆட் பேரிட்டி ஜெனரேட்டர் யூ பீப்புள் ட்ரை ஆன் யுவர் ஓன். ஓகே, நீங்களே ட்ரை பண்ணி பாருங்க. ஃபைன். ஸோ நவ் we will move to parity checker. Kindly take a screenshot of this. Shall I proceed to next slide? Yes. Okay. Fine. So now parity checker. Fine. So parity checker, at which side we are going to use? Transmitting end or receiving end? Slide number 20, 21 venumappa. Kindly take a screenshot quickly. 20, slide number 20. Now I will show slide number 21. 21. Okay, fine. So now I will move to parity checker. To which end we have to use parity checker? Kindly type it in the chat. When we are transmitting a message, we are generating the parity bit and we are sending it. Correct? Yes, Srihari. At receiver side, we have to go with parity checker circuit. Fine. So parity checker, what it is going to do? The parity checker circuit checks the parity of the information received from the transmitter. Okay. So that we call it as parity checker. Okay. So parity checker is a combinational circuit that checks the parity of the information received from the transmitter. Fine. The circuit will check the possible error in the received information. Say for example, what we have designed previous நம்ம என்ன circuit design பண்ணப்பா? Odd parity generator or even parity generator? Even parity generator. அப்ப செக் பண்ற சைடுல எனக்கு என்ன இருக்கணும்? Even parity checker we have to design. Is it clear what I am saying? See, transmitter, if it is always sending even parity data, receiver என்ன செக் பண்ணணும்? Even parity இருக்கான்னு மட்டும் தான் செக் பண்ணணும். Fine? Okay. So the circuit will check possible error in the received information. So consider a transmitter sends an information, message plus even parity bit to a receiver. Correct? என்னோட transmitter என்ன send பண்ணிருக்கு? மெசேஜ் கூட ஈவன் பேரிட்டி பிட்டை சென்ட் பண்ணியிருக்கு. அப்போ ரிசீவர் என்ன செக் பண்ணணும்? வாட் த ரிசீவர் மஸ்ட் செக்? Message along with the parity bit must be even. That indicates there is no error in the data. That means the parity checker at receiver must deduct an even parity for the received information. Okay, which indicate received information is error free. Suppose எனக்கு odd parity deduct ஆனா meaning என்ன? Parity checkerல odd parity deduct ஆனா meaning என்ன? If it deducts odd parity, what it means? Even parity checker we are using. Suppose if it produce odd parity, whether I will get error or not, whether the information is having error, yes, it is going to have error. Fine. So now we will design parity checker circuit. So 4-bit even parity checker. So why 4-bit? Already நம்ம மெசேஜ் என்ன சொன்னோம்? 3-bit plus parity bit. So இப்போ டோட்டலா எத்தனை பிட் ஆயிடுச்சு? 4-bit now. So consider, here you consider A is the parity bit, B, C, D are the message bits. Okay. Actually, இங்க P ன்னு போட்டிருந்தா மீனிங்ஃபுல்லா இருந்திருக்கும். That's what I am telling. For your understanding, you can name the variable. நான் இங்க என்ன பண்ணிருக்கலாம்? P, A, B, C ன்னு நேம் பண்ணிருக்கலாம். Instead of A, B, C, D, how I can rename? P, A, B, C. ஏன் P first சொல்றோம்? Can you people type it in the chat? இங்கே ஏபிசிடி நம்ம நேமிங் பண்ணியாச்சு. ஃபைன், இது அப்படியே படிச்சுக்கலாம். எஸ் ரிஸ்வான், ஆஸ் இட் இஸ் பேரிட்டி பிட், எம்எஸ்பி பிட் பேரிட்டி பிட், ரிமைனிங் பிட்ஸ் தான் எனக்கு என்னது? மெசேஜ் பிட்ஸ். எப்போவுமே சீரியல் கம்யூனிகேஷனில் த மெசேஜ் இஸ் டிரான்ஸ்மிட்டட் ஃப்ரம் எல்எஸ்பி டு எம்எஸ்பி. ஃபைன், அப்போ லாஸ்ட்டாக ரிசீவ் ஆகிறது தான் எனக்கு என்னது? பேரிட்டி பிட். தட்ஸ் வை வி ஆர் நேமிங் லைக் திஸ். ஃபைன், கன்சிடர் த அவுட்புட் ஆஃப் த பேரிட்டி செக்கர் இஸ் denoted by PEC. The variable name what we are using is PEC, parity error check. அப்படின்னா மீனிங் என்ன? When this output is high, that indicates there is an error occurred in the transmission. Okay, if PEC equal to 1, an error has been occurred. அப்போ 4 bits எனக்கு ரிசீவ் ஆகிறது odd number of ones இருக்கலாம். If PEC equal to 0 means there is no error in the received data. Is it clear for all of you? Yes or no? So PEC is my output. Okay, if PEC equal to 1, we are having error. If PEC equal to 0 means no error. எப்பெல்லாம் எரர் இருக்கோ இப்போ எனக்கு PEC என்ன இருக்கணும்? 1 இருக்கணும். Is it clear? Yes. Okay, now we will design a circuit. So அதுக்கு முன்னாடி என்ன பண்ணணும்? Variables assign பண்ணியாச்சு. What about the next step? A, B, C, D are the inputs. PEC is my output. So 4 inputs, 1 output. What about next step? If the number of input variable is lesser than 6, we can use truth table with K-map. So truth table பார்த்தோம்னா இப்படி இருக்கும். Fine. We will check random inputs. I'm going to consider the combination 0, 1, 1, 1. Okay. What we are checking? Even parity checker. அப்படின்னா மீனிங் என்ன? 0, 1, 1, 1. 3 ones are there. Whether it is having an error or not? 0, 1, 1, 1 na odd parity. That means the received information is having error or not? Yes or no? Yes. So what about PEC now? It is 1. So like that I have filled the output for 16 combinations. Is it clear? If it transmit 1001 but receives 1100, here the position if bit has changed, no sir. Is it an error, sir? Yes, definitely it is an error, but it cannot be deducted by this circuit. Okay, that's what we are saying. This parity code is used to deduct only 1 bit change. எனக்கு டிரான்ஸ்மிட் ஆகிற மெசேஜில் ஏதோ ஒரு பிட் மட்டும் எனக்கு சேஞ்ச் ஆனால் I can identify the error. Otherwise, you cannot identify it. Okay, Srihari? See, when you are transmitting a small number of bits, 8 bit நான் சென்ட் பண்றேன் அப்படின்றப்ப we can go with parity bit. Okay, because when you are transmitting some 8 bits, the possibility of error occurrence is very, very less. probability ரொம்ப கம்மி. Fine. We are assuming for small data length, for small messages up to 8 bit, we can go for this parity code. Okay. If it is beyond 8 bit, we can use some other method. I'm already சொல்லிருக்கோம் இல்லையா, Hamming code, CRC, many methods are there. Shall I proceed? Shall I proceed? So this method have some limitation. That's what Sajid sir is typing. Okay. So this method, it is having some limitation. Okay. Now you people type it in the chat. What about the minterms we are having from this expression? Sorry, from this truth table. What are all the minterms we are having? What about the minterms for PEC? The output function PEC க்கு என்னென்ன mintermsலாம் வரும்பா? Minterm 1, 2, 4, then 1, 2, 4, 7, 8, 11, 13, 14. Very good, Jivita. So for this, we are going to have the K-map. So here also, there is no possible to group the ones. So single grouping தான் இங்கேயும் போறோம். Fine. So when you solve this expression, இது எல்லாத்தையும் எடுத்து solve பண்ணீங்கன்னா, we will be getting the answer A XOR B XOR C XOR D. That means A, B, C, D all are must be performed with an XOR operation. சில வேரியபிள் காமனா எடுக்கிறது ரொம்ப சிம்பிள்ப்பா. இந்த K-map வச்சே பார்க்கலாம். இங்க என்ன ரோல காமனா இருக்கு? A bar B bar. காமனா எடுத்தா எனக்கு என்ன வரும்? C bar D plus C D bar. அதே மாதிரி இங்க என்ன இருக்கு பாருங்க? A bar B. காமனா எடுத்துக்கோமா நெக்ஸ்ட் டேர்ம்ல C bar D bar plus C D. ஒரு ஸ்டெப்பை ஸ்கிப் பண்ணிட்டு ஸ்ட்ரெயிட் அவே இது எழுதி இருக்கும். Actually you have to write 8 minterms. அதுல என்ன பண்ணலாம்? A bar B bar you can take common from 1 and 2. Fine. இது ரெண்டுத்துல எனக்கு என்ன பண்ணலாம்? A bar B எடுக்கலாம். இது ரெண்டுத்துலயும் AB எடுக்கலாம். இது ரெண்டுத்துலயும் AB bar எடுக்கலாம். So like that we have written here. Fine. So first அந்த ஸ்டெப் எழுதிட்டு அதுக்கப்புறம் இதை எழுதுங்க. So that you can understand. Is it clear? Is it clear? Yes. Okay. Now I will tell you one shortcut method. Okay, one shortcut method I will tell you. இந்த செல்ஸ் நான் ஃபில் பண்றப்ப எப்பெல்லாம் எனக்கு இந்த மாதிரி ஃபர்ஸ்ட் பொசிஷன்ல எதுவும் வராம செகண்ட் பொசிஷன்ல 1 தென் ஒரு பிட் விட்டு இன்னொரு பிட்ல ஒன்ஸ் ஃபில் பண்றோமோ டெஃபினெட்லி யூ வில் ஹாவ் த ஃபங்க்ஷன் லைக் A XOR B XOR C XOR D. 3 வேரியபிளா இருந்தாலும் சரி 4 வேரியபிளா இருந்தாலும் சரி வாட் எவர் இட் மே பி. Okay, you can observe the K-map table of adder subtractor. 3-bit adder subtractor எடுத்து பாருங்க. எது எடுத்தாலும் நமக்கு என்ன கிடைக்குது? If we are having all this alternate cells with single grouping இருந்துச்சுன்னா அது என்ன சொல்லலாம்? A XOR B XOR C XOR D ன்னு சொல்லலாம். இதே first position இங்க வராம இந்த 1 இங்க வந்துட்டு if it is like this 1 0 1 0 1 0 1 0 like that alternate எனக்கு மாறி வந்துச்சுன்னா இதே இது 0 உள்ள இடத்துல 1 1 உள்ள இடத்துல 0 வந்துச்சுன்னா you can simply say A XNOR B XNOR C XNOR D. Fine. So நீங்க odd parity checker போனீங்கன்னா you can get the expression like A XNOR B XNOR C XNOR D. It will come like that only. Fine. Now logic diagram for a 4-bit even parity checker. A XOR B, C XOR D. Again, both are XOR together. So that is the outcome PEC. Fine. So that's all about the 4-bit even parity checker. See, if I am having an n-bit generator, I must have n plus 1 parity checker. Fine. The purpose of this circuit is to detect the error. If the output is high, shall we use 5 input XOR gate? Actually, commercially, we will be having 4 input XOR gate. Okay, commercially, 4 input XOR gate இருக்கும். So, இப்போ A, B, C, D எல்லாத்தையும் கொடுத்துக்கலாம். Yes, we can use Srihari. Okay. So now we'll move on with the next topic. Or introduction பார்க்கலாம். Fine. I hope it can be finished within this session. Okay. Yes, another 15 minutes there. Okay, we will check. So implementation of basic gates using NAND and NOR gate. Okay. So already once we have told NAND and NOR gate can also be called as what? And or X, NOT gate, AND gate, OR gate. இது மூணு நம்ம என்ன சொன்னோம்? Basic gates. Very good, Srihari. NAND and NOR gate can also be called as universal gates. What Srihari typed is correct. Can term it as universal gates. Fine. We will see that NAND and NOR gates are called as universal gates. So this is the symbol of NAND gate and NOR gate. The first one is NOR gate, second one is NAND gate, and the expression for the output is also marked here. Fine. Why they are called universal gates? Why these two gates are called as universal gates? Can you people type? Combined with the basic gates and NOT. Any idea? Any idea? Combined with the basic gates and NOT OR. With this gate, we can perform basic gate function also. Very good. That is the correct answer, Rizwan. Okay. So the basic gates and or NOT gate can be implemented using NAND and NOR gate. So how we can implement those things, that only we are going to see now. Fine. First, we will consider NOT gate using NAND gate. Fine. How it can be created? How many number of inputs for a NAND gate? Minimum NAND gate la எத்தனை input இருக்கணும்பா? Minimum number of inputs for NAND gate 2. Very good. Okay. What about the case of NOT gate? Maximum எத்தனை input இருக்கணும் NOT gate க்கு? Only 1. Fine. So இப்போ 1 input 1 output எனக்கு வரணும். So what I have to do with the NAND gate is just short the pins of 2 inputs. 2 input short பண்ணி நான் என்ன பண்றேன்? I am taking it as single input. Fine. Now you can know the left hand side. X NOT gate பண்ணோம்னா X bar கிடைச்சிரும். இங்க என்ன கிடைக்கும் பாருங்க. If I am giving same input to both, if I am giving the same input to both points, ரெண்டு இன்புட்லயும் நான் என்ன கொடுக்கிறேன்? சேம் இன்புட்டை கொடுக்கிறேன் X. What about the final outcome? What about the expression for NAND gate? If I am giving 2 input A and B, if I am giving 2 input A and B, what about the outcome of NAND gate? Very good, Srihari. He typed X and with X whole complement. Yes, Srihari typed A dot B whole bar. Okay. Here A and B are simply X. So X dot X whole bar. What is X dot X? According to Boolean theorem, X dot X na enna sollirkom? X dot X. X only. So X dot X whole bar is nothing but X bar. Is it clear for everyone? So NOT gate வேணும்னா just என்ன பண்ணணும்? NAND gate ஓட inputs short பண்ணிட்டு we can give the single input. So we will get the complement of the output. Is it clear for everyone? Yes? Okay. Next. AND gate using NAND gate. எப்படி பண்ணலாம்ப்பா? Any idea? If I am giving 2 inputs, already இப்பதான் பார்த்தோம் A, B அப்படின்னு கொடுத்தோம்னா NAND gate output என்ன கிடைக்கும் எனக்கு? A dot B whole bar கிடைக்கும். Fine? I have typed in the chat. How I can obtain AB from this? ஒரு NAND gate நான் யூஸ் பண்ணனா output எனக்கு என்ன கிடைக்கும்? A dot B whole bar கிடைக்கும். What is the procedure to get AB again? Yes, NOT gate. How we can do NOT gate in terms of NAND gate? Already we have mentioned here. So the circuit will be like this. Nalla gavaninga, x dot y whole bar. Okay. Now it has to be complemented. This is nothing but NOT gate. Inge pathina theriyudha? NOT gate equivalent தான் இங்க நம்ம derive பண்ணியிருக்கோம். That means a NAND gate output is given as same input to another NAND gate produce an AND operation. So இப்போ xy கொடுத்தோம்னா ஃபைனலா எனக்கு என்ன கிடைக்குது? I will get xy, x dot y. Is it clear for everyone? Is it clear for everyone? Yes. Okay. Fine. Next OR operation. We can do like this. நல்லா கவனிங்கப்பா. OR operation எப்படி நம்ம பெர்ஃபார்ம் பண்றோம் அப்படின்னு பார்த்தீங்கன்னா, I will write it. Actually the thing is, if I am opening the screen, பென் எனேபிள் பண்ணா உங்களுக்கு ஆஃப் ஸ்கிரீன் தான் விசிபிளா இருக்குன்னு சொல்றீங்க. Is full screen is visible now? Is full screen is visible now? Yes or no? I may not able to see your chat now. I will minimize this and we will see the chat. Yes. Okay. So now I will try to write it here. So I have to perform x plus y. Okay, in terms of NOR gate. So how I can write x plus y? X bar dot y bar the whole bar. It can be written like this as it is here. Correct? X bar dot y bar the whole bar. To perform x bar, we are using one NAND gate. To perform y bar, we are using another NAND gate. Fine. Now it is a dot b whole bar. To perform that, we are using the third NAND gate. Fine. So the final expression become x plus y. Is it clear now? Is it clear now? Is it clear now? Okay. Now, the same thing. That means we can also derive AND gate, OR gate and NOT gate using NOR gate. Same. X plus x whole bar becomes x bar only. Correct? Now, to perform OR gate using NOR gate, simply the output of NOR gate can be complemented again using NOR gate itself. Finally, take a screenshot. நல்லா கவனிச்சிங்கன்னா தெரியும்பா, x plus y whole bar. Correct? அதை again complement பண்ணா எனக்கு x plus y கிடைச்சிருது. That's it. Shall I proceed to next slide? Yes? Yes. Okay, AND gate using NOR gate means first you have to complement both the variable x and y. So x bar, y bar. If you perform NOR operation, x bar plus y bar whole bar, that is equal to x dot y. That's all. Is it clear? Is it clear for all of you? So note down the equivalent circuits using NAND gate and NOR gate. Okay, you take a screenshot of this. NOT gate, AND gate using NAND gate. இப்படி தான் பண்ணணும். Fine. OR gate. So hereafter you have to know this equivalent circuit of OR gate or AND gate or NOT gate. Take a screenshot of this. I will move to next slide. Can we implement NAND using NOR? Yes, you can use. Now you have all the basic gates. Correct? So what you can do? See, simply this is an AND gate using NOR gate. Correct? If you complement this output again, what will be the thing? X dot y whole bar, complement of NAND. Clear? Complement of this circuit. This is a AND circuit. Correct? 3 XNOR gate வச்சு நான் என்ன பண்ணியிருக்கேன்? 3 NOR gate வச்சு. Using 3 NOR gate, I have developed a AND gate. If you complement the output of this, again you will be getting NAND gate. So using NOR gate, you can implement NAND gate also. Okay, fine. So now we are going to implement any Boolean function using universal gate. Implement the logic circuit of the given Boolean function using basic gates. Okay, first thing to design any circuit using NAND or NOR alone. NAND gate mattu vechi pannano illa NOR gate mattu vechi pannona, first enna pannano? You have to do with basic logic gates. First step you have to do AND gate, OR gate, NOT gate. Idu mattum dhaan irukkanum. Fine. Next step, replace each basic gate with the equivalent logic circuit using NAND or NOR gate. Now நம்ம பார்த்த equivalent circuit you have to replace in that particular basic gates. Fine. If anywhere you find 2 NOT gate in series, correct? 2 NAND gate in series illa NOR gate in series வந்துச்சுனா remove those two. Fine. I will show you an example so that you can understand it. Implement the function f equal to ab plus cd plus e using only 2 input NAND gate. Shall we implement? What about the first step? We have to implement it with the basic gates, correct? Shall we implement? So how many AND gate and OR gate we need now? Can you people type it in the chat? How many AND gate and OR gate we need? We told 2 input NAND gate we are going to use. எல்லாமே 2 input consider பண்ணிக்கலாம். A and B perform பண்றதுக்கு ஒரு AND gate வேணும். C and D perform பண்றதுக்கு ஒரு AND gate வேணும். So 2 AND gate. Correct? Yes, 2 AND gate, 2 OR gate. Very good. Is this circuit is clear for everyone? AB plus CD plus E. Is it clear for everyone? Yes or no? Yes. Now we have to replace the AND gate and OR gate with equivalent circuit in NAND gate. Using NAND gate, how we implemented AND and NOR, sorry, AND and OR gate, that we have to replace. So it become like this. Correct? So this one is AND gate, this one is one AND gate, A and B. Correct? Here it is C and D. Correct? Again, these two things you have to perform OR operation. So the OR gate looks like this. 2 AND gate parallel with series to an NAND gate. 2 NAND gate. The output of the NAND gate is connected to another NAND gate. So it works as a OR gate. Same here also. Is it clear up to this? Is it clear up to this? இதையும் இது ரிலேட் பண்ணி பாருங்க. AND கேட் என்ன ரீப்ளேஸ் பண்ணியிருக்கோம்? 2 NAND கேட். OR கேட் எப்படி ரீப்ளேஸ் பண்ணியிருக்கோம்? 3 NAND கேட். Is it clear up to this? Yes or no? Application of this circuit. Okay. Sabari's asked one question. What about the application of this thing? See, when you are designing an IC, you must use only the universal gates. Okay. There are a lot of reason for this. Okay, you people go and search in Google, okay, and you refer some textbook and come with the answer in the next class. Very good, Stigari. Low cost, easy to fabricate because less hardware is required. Okay, the reason behind this, elaborately you go with the internet or refer some textbook. Okay, எந்த ஐசி நீங்க எடுத்துக்கிட்டாலும் அதுல உள்ள இன்டர்னலா என்ன யூஸ் பண்ணிருப்பாங்க? To implement any function, all the gates are either NAND or NOR தான் இருக்க முடியும். What Srihari told is correct. Low cost. Why low cost? Less hardware, less number of transistor. We can implement all the circuit. Fine. Once it is over, the last step is wherever we find 2 NOT gate in series. இது ஒரு NOT gate, இது ஒரு NOT gate. NOT of NOT what? A bar whole bar. What it come? A bar whole bar. A. So instead of using two NOT gate in series, you can strike it out. எங்கெங்கெல்லாம் ரெண்டு NOT gate சீரீஸ்ல வருதோ அதை ஸ்ட்ரைக் பண்ணிடலாம். ஸோ ரிமைனிங் மட்டும் எடுத்து வரைஞ்சோம்னா we will have a circuit like this. We will have a circuit like this. You just derive the function for this. Okay, now I will maximize the screen and I will write the output function. I don't know whether you people can see it clearly. So I'm making it full screen. Whether it is visible for all of you? Whether the screen is visible for all of you? Yes or no? No. Okay, fine. Now I will try it. Whether it is visible now? Whether the screen is visible now? Kindly type it in the chat. Yes, okay. So I will follow the same steps. Okay. Now what I am going to do is, I am going to derive the function. So A NAND with B, that means A dot B whole bar. A dot B whole bar. Find here C dot B, oh sorry, C dot D. Sorry, it is C dot D the whole bar. What about the output here? A bar, sorry, A dot B whole bar dot C dot D whole bar the whole bar. So how it becomes? How it becomes? A dot B whole bar plus C dot D whole bar. So this entire thing become AB plus CD. AB plus CD. So here, fine. So AB plus CD, here we know it is not operation. So here it comes AB plus CD whole bar. AB plus CD the whole bar. Fine. So here we get E bar, correct? Here we get E bar. So now here we get AB plus CD whole bar dot E bar whole bar. So the entire thing becomes AB plus CD plus E. That is the answer. AB plus CD plus E. That is the answer. Fine. So the same function we have implemented like this. Kindly take a screenshot of this. Kindly take a screenshot of this. Is the screen is visible for all of you? This is the final circuit. Okay. I think time nariya aidichupa. Here we will stop. Sorry, I didn't notice the time. So here we will stop. So you note down this task. You do it on your own. Kindly take a screenshot. The same thing you have to implement with 2 input NOR gate. Okay. So with this we will stop the recording. We will stop the session.